Today we're looking at solving trig equations. This is mostly applicable to National 5, but also applicable to higher. What we'll be doing is we'll be looking at some simple type equations to some that are a bit more complex. And what we'll be doing is we'll be trying to find out the angle there that makes the equation true. Now, first of all, what I'd like to start with is to go through a process that I'll be following with each of the questions that we'll be looking at. And what we're going to do is, first of all, we're going to determine whether the value is going to be positive or negative. We'll then find the quadrants that the angles are going to lie in, and we'll be using a cast diagram for that. We'll be finding the acute angle first of all, and then what we'll do is, beyond the acute angle, we'll then find the other angles that will be the solution to the equation. And the solution that we're going to be looking at will really lie between 0 and 360 degrees. And what I'd make sure is, when you do answer a question on this type of work, make sure you look at the range that's been given, because that will limit the answers that you'll have to give. And what we're going to do is we're only going to use the 180 and 360 degrees when we try to calculate some of the angles that we're going to be looking at. Okay, so to start off with though, what I'd like to say is that the expectation I have here is that you know the sine graph, you're well acquainted with that. You know that the sine graph starts at 0, has a period of 360 degrees, and it goes upwards to a maximum of 1 at 90 degrees. It goes back to 0 at 180 degrees, down to -1 at 270, and then back to 0 at 360, where it then goes and repeats. If I look at the cosine graph, just as a quick reminder, cosine graph starts at 1, so from 0, it starts at 1, comes down through 90, comes down to the bottom, to the minimum that it's got at -1, and that will be at 180 degrees. It then comes back through the x-axis at 270 degrees, and then it completes at 360 degrees, and that would be up at 1 there as well. So that would be the maximum of the cosine graph. The tan graph has a period of 180 degrees, so before it starts repeating, it starts at 180. Okay, and what I'm expecting there is that you know that the graph goes from 0 and it never touches 90. It then starts down below, comes up through here, and at 0 it's 180 and goes up the way at 270. Starts down at the bottom again and comes back here, and that will be 2 cycles that we have in 360 degrees. Okay. Also, what I'd like to say is that for those that are doing this in higher, then I would expect that you would know the table of exact values. For this case here, we're doing it in degrees. We're not working in radians with this section, but you would know the answers here in the table of exact values. Okay, so let's start off, and we'll look at a couple of questions. First ones I'm going to start off with will be some that are relatively simple, and these ones here in the first slide that we've got sine x equals 1, sine x equals 0, cos x equals -1, and tan x equals 0. Now, whenever I see a 1, a -1, or a 0, what I'd be trying to think about is thinking about what it would look like on the graph. So if I was doing this question here and trying to solve this question here, what I'd be looking at is thinking about the sine graph. So remember, the sine graph starts at 0, comes down from here and goes back to 360 degrees here. 180, I've got 270 degrees here, and here I've got 90. So what I'd be expecting to look at would be that where is the graph, where would the curve be equal to 1? So the place that would be equal to 1 will be here, and that would be 90 degrees. So for this one here, I would just expect to say that x is equal to 90 degrees, and nothing more than that. So I wouldn't use my calculator for this type of work, and I wouldn't use the table of exact values either. I would be looking at using the graphs. Okay, let's look at B, sine x equals 0. So again, just think about the sine graph. So we know that the sine graph finishes at 360, goes through 180 and 0, goes up to 1 and goes to -1. So I know that where would the graph or the angle be equal to 0 on this graph? I can see I've got 1 point here, 1 point here, and 1 point here. So I've really got 3 answers to this question. So I've got x is equal to 0, 180 and 360 degrees. The cosine graph now. Cosine x equals -1. So let's think about the cosine graph. So the cosine graph starts at 1, comes down through the axis, comes down to a minimum there, and back up there to a maximum. This point here is 360, half of it is 180, 270 back through the axis, and 90 there. It's going to start at 1 and down to -1. So whereabouts is the value going to be -1? So it's going to be here, right on that point, only one answer to this, and the answer there is going to be x is equal to 180 degrees. Tan x equals 0. So if I think of the tan curve, so what I've got is a tan curve. So the tan curve goes up like that at 90 degrees, and then it starts back down here, comes through at 180, and back up to there at 270, coming from here and to there at 360. So what I'd be looking at is where would it equal 0? So I've got 1 point here, 1 point here, and 1 point here. So I'm going to be saying that x is equal to 0 degrees, 180 degrees, and 360 degrees. Okay, so they're the ones that I would generally look at the graph. What we'll move on to is ones that I'll either use the table of exact values if I'm working at higher level, or I'd be using my calculator to work these next ones out. Okay, so what I've got here is sine x equals 0.5. Now if I think of what that's really asking me to do, if I look at the sine graph that I have here, what I'd be really interested in is whereabouts on the graph would I find a value of 0.5. So if I draw a line along here, I've only got 2 values, so what I'd be looking at graphically, one value there and the other value there. Okay, so that's really what I would be doing if I was looking at the graph, but I wouldn't be able to do it accurately enough if I had a different value than 0.5. So what I would then do is I'd really be thinking about looking at the cast diagram again. So if I think of the cast diagram and the way that that's made up, remember that in this quadrant here, quadrant 1, that I can see that all the angles are positive in here. If I look at the second quadrant, which will be this part here, I can see that only sine is positive, and that's where we get the S from for here. In this third quadrant here, the third quadrant, I can see that tan is the only one that's positive here. And in the final quadrant here, the fourth, what I've got is I can see that the only one that's positive is the cosine graph, and I can see it from my cast table there. Now what I'll be doing through the questions that we've got from now on, I'll be finding an angle that's in here, which will be the acute angle. So that will be x, and it will be in degrees. I'm then going to try and find a related angle that will be either in this quadrant, this one, or this one. And the way I'm going to find that out after I've found the acute angle, I'm going to start with 180 degrees, and I'm going to substitute x to find out the value in that quadrant there. Now if I think about it sweeping round from here, to find a value in this quadrant, what I'll have is 180 degrees, and that will be plus the value that I find as my acute angle. If I'm going to try and find a value that's in the fourth quadrant, I'm going to start at 360 degrees, and I'm going to subtract the acute angle that I find. So this is the way I'm always going to be working out this type of question. Okay, so back to the graph. We're looking at this one to come up with an answer of 30 degrees and 150 degrees when the graph is equal to 0.5. So let's go and try and show that. Okay, so the first thing that I'm going to do here is I'm going to always try to get these equations with just the sine x on its own. or cos x or tan x on its own. What I'll then do is I'll take the inverse of it. If I find the inverse, then what I can do is I can find the acute angle. So what I'll do is I'll find the acute angle first. Okay, and what I'll be doing first even before that, I'll be looking in there and finding out, is that a positive or a negative value? Well, obviously it's a positive, okay, so it's a positive value, and I'll be thinking about my cast diagram. So I'll then know that this is all sine, tan and cos. So if sine is positive, all angles are positive there, and only sine is positive there. So I'm looking for two solutions to come out of this, this equation. One in the first quadrant, the other one in the second quadrant. So I'll find the acute angle this time, and I'll go for x is equal to the inverse sine, and that's going to be of 0.5. If I work that through on my calculator, all that I'd be doing there on the calculator will be, I'll just be pressing the shift button at sine and 0.5, closing the bracket, and there it should give me an answer of 30 degrees. Okay, so that's given me 30 degrees as the acute angle. In this case, because it's positive, the acute angle is one of my solutions. I'll then find the quadrant 2 solution. I'll just call it quad 2. And that's going to be 180 minus the angle that I've just found as the acute angle. And that should give me an answer of 150 degrees. And that was just like it was in the graph that I'd shown you earlier. So my solutions, x is equal to 30 degrees and 150 degrees. And that's that finished. Okay, this one here looks a bit more complicated than this one here, but let's try and get sine x on its own. Right, so what I'll do first of all is I'll divide both sides by 6. So I'll have sine x here, and I'll have 3 all over 6. Now if I sort that out a bit, I can just simplify this fraction down, and what that will give me is sine x equals a half. Now, a half is just the same as 0.5, so all I'll be doing with this one now is the exact same work as I did there. So really what I'm trying to do, remember, is just get sine x on its own with a value on the right hand side. So again, all I'd be doing is looking in there, is it positive or is it negative? It's a positive number. I'd be then thinking about the cast table, and I'd be looking at where I'm going to find my values. If it's positive, it's in there. If it was a negative value, it would be in there. I'd be looking for the two solutions. So I know that the acute angle is 30 degrees. I had a quadrant 2 angle, 150. So without having to do the work again, in here, my solutions are going to be x equals 30 degrees and 150 degrees. So it's just the exact same thing. So just try to simplify the equation down. Okay, let's look at some others. What we'll do is we'll look at this equation here. The first one that we're going for is cosine x is equal to a half. Right, so for this one here, what I'm thinking about doing is thinking about the cosine graph, but with it being a 0.5, I may have to think about the cast table to get my values here. Right then, so I'm going to look in there again. Is that one there positive or is it negative? And it's a positive value, so what I'm looking at from here is all sine, tan and cos. I'm going to be looking at a value in there because all angles are positive there, and it's the cosine is positive, so it's an answer in there. So it'll be the first and the fourth quadrant that I'm looking for. Right, so to find the acute angle, what I'll do is I'll take the inverse cosine of 0.5. Okay, if you're doing higher, you look at the table, or you think about your table of exact values and work that out. If not, if you're doing National 5, what I'd do is I'd do the inverse cosine and would put 0.5 in the calculator, and that should give me an answer of 60. So that'll give me 60 degrees here, which will be one of my solutions. The quadrant 4 solution, remember it's going to be 360 minus what I find here, which is 60 degrees. So that gives me 300 degrees. Okay, so my solutions are going to be x is equal to 60 degrees and 300 degrees. What you can do is you can try and freeze the video if you'd like to do that and try some of the questions as we go along. And you could even freeze it halfway through a question, see if you can complete the question yourself. Okay, let's go on to question H. Right, I'm going to have to sort this one out because this one here just said cos x on its own. What I want to do is to get cos x on its own for this question here to try and solve this one. Right, what I'll do is I'll get that 3 over to the other side first of all. And what that should be is 1, and that'll be subtracting 3 if I take it over to that side. So if I just tidy that up just now, that's going to be minus 2 I'll have there, the 1 minus the 3. And then to get cos x on its own, I'll need to divide that side there by the 8. So that'll be cosine x is equal to minus 2 over 8. But I can simplify that down a bit further, which will be 1 over 4. So it's cosine x is equal to minus 1 over 4. So that's as if I'm starting with this question here, the way it would be, but with minus 1 over 4. Right, so I'm looking in here again, so I'm asking myself, is that positive or is it negative? I'm then going to think about the cast diagram, all sine, tan and cos, and if that's negative, I'm looking for where the cosine of an angle is negative, so and it's going to be where it's not positive. So cosine's positive here and here, so I must be looking for the solutions in here and here in quadrant 2 and quadrant 3. But first of all I must find the acute angle to help me out. So the acute angle is going to be the inverse cosine, and I'm going to be using 1 over 4. So no negative used here. Okay, because I just want to find out what the acute angle is. So if I go into my calculator, and what I do is I punch in inverse cosine of, I'll just go for 1 divided by 4. If you use fractions you can put it in as a fraction, and what I'll get out of that will be 75, and we'll just go for 1 decimal place for this one here. So 75.5. From there, what we'll go for is we'll go for our solution. So this one here is not a solution. Remember, I'm only looking for solutions that are going to be sitting in quadrant 2 and quadrant 3. So I'll go for my quadrant 2, and that's going to be, the x is going to be equal to 180 minus 75.5. And I'll be looking at my quadrant 3. And that's going to be x is equal to 180 plus 75.5 degrees. Okay, and I can use my calculator if it was a calculator question, which it would be for this. And what we get is 104.5, and then we've got 255 for that one there. Okay, so my solutions. X is equal to, and it's only going to be 104.5 and 255.5 degrees, not the acute angle that's here. And I'm just writing out the solutions so that it's clear what I'm seeing as the solutions and not including all of the working that I've done there. Okay, let's look at another. Let's go for these questions here. So I've got another 4 questions to do. I've got a couple of roots in here. Those that know the table of exact values should be able to work out this on their own. What I'll do is I'll just work through the questions for those in National 5. And what we're going to do first of all is we're going to be looking at, is that positive or it's negative? So obviously it's going to be negative. I'm going to be looking at the cast table, and because it's sine, I'm going to be looking at where sine is not positive. So it would be positive here and positive there. So because it's negative, I'd be looking in these 2 quadrants here for my solution. So what I'll do first of all is I'll try and find out the acute angle, because the acute angle is the one that's going to help me find my solutions. So it's going to be x is equal to the inverse sine, and that's going to be of root 3 over 2. So again, remember, there's no negative value in there, so no negative. So I'm just wanting to find the acute angle. So what I'd do if I'm working on my calculator here, all I would do is I'd do the shift sign, and what we'd do is we go for the root 3, I'd close that bracket there, and what I'd do is I'd just divide that by 2. And what I should get there is 60 degrees. Okay, from the table of exact values, you should be able to pick that out as well. So that's going to be 60 degrees here. Right then, so I'm looking for answers in the third quadrant. So I'll go for quadrant 3. Quadrant 3 answer is going to be x is equal to 180 plus the 60 degrees. And for my quadrant 4 answer, what I'd be interested in is the 360 minus 60 to get my solution from there. So in here I've got 240 degrees, and in here I've got 300 degrees. Okay, so my solutions, x is equal to 240 degrees and 300 degrees. Okay, let's look at this question here. On the right hand side, what we have is, it just looks a bit more complex, but again all we're trying to do is to get cosine x on its own. So really what I want is on the left hand side, I just want that to be left on the left hand side. Let's get that minus 1 over to that side first of all, and what I'd have is root 2 cosine x, and I'll have minus 2, and that will be a plus 1 when I take that over to the other side, or all I'm doing is adding 1 to each side. Right, so I've got root 2 cosine x, and that's going to be equal to minus 1, and then what I'll do is I'll just divide it by the root 2. So what I've got on this side is cosine x is equal to minus 1 over root 2. Right, from there I'm going to find out whether this is positive or negative. Obviously it's negative. What I'll do is I'll look at my CAS table and look at where I'm looking at for my solutions. So cosine is going to be negative, so I know it's positive there and there, so it must be negative there and there. So that's the two solutions that I'm going to be looking for. So I'll then find the acute angle to help me out. Right, so what we'll do is we'll say that x is equal to the inverse cosine of 1 over root 2. And again, this is on the table of exact values for you, and that should give us 45 degrees. So if I'm using my calculator, all I would punch in would be 1 divided by root 2 for that one there, and close the bracket. I'm going to find the quadrant 2 solution first of all. So the quadrant 2, so that's going to be 180 minus 45 degrees. And for my quadrant 3 answer, or solution, I've got 180 plus 45 degrees. So up here I've got the first solution, which will be 135 degrees, and in here what I'll have is 225 degrees here. So my solutions, x is equal to 135 degrees and 225 degrees. Okay. So the last two questions is coming up, and what we have here is I'm going to look at tan. So I'll look at tan x. Tan x is equal to 4. Okay, so just to show you what that would look like in the graph. So where tan x is equal to 4, so if I just think about the graph being drawn here, so there's 4 there. So if I draw along this line here, and just extend that a bit further, I'm really looking for two solutions. One of the solutions should be here, and the other solution I should be getting down round about there. Okay, so that's really what I'm trying to do. I'm trying to find out these values that are there and there from this tan graph. So I'm looking for two solutions again. I'm just going to follow the normal process that I've been doing to try and find that out. Now I've got tan x on its own, so that's relatively straightforward to work with there. So what I'm looking at in there, is it positive or is it negative? It's positive, isn't it? So what I'll be looking at is finding out where it's going to lie. So if tan x is positive, looking for a solution here, and I'm looking for a solution here. So that's in the first and the third quadrant. Right, so I'll find the acute angle. So the acute angle is going to be tan to the minus 1, 4. Okay, so just on my calculator, just do inverse tan, and we'll punch in 4, and that equals, let's go for 2 decimal places here, let's go for 75.96 degrees. Now, a word of warning here with the numbers that we see here. The only time that you'll see a number that should be greater than 1 will be when we're working with tan. If we find a sine x equals 4, then there will be no solution to that, because the graph does not go up to 4. The normal sine, or the y equals sine x graph, only goes up to 1 and down to minus 1. So if we have a value outside that range, then what we're looking for is to write down no solution. Okay, so let's find our other solution here. So that would be our quadrant 1 solution. So let's go for quadrant 3 now. And what we've got is, when we're working at quadrant 3, remember it's 180 plus the angle. And what we get there is 255.96 degrees. Okay, so that would be our 2 solutions that we're going to come up with there. So the solutions, I've got x is equal to 75.96 degrees, and what we've got is 255.96 degrees. That would be my 2 solutions for there, in the first quadrant and in the third quadrant. Right, so just rearranging this question here. You can pause this one and try and complete it. I'll just show you the solution just now. Okay, I'm going to get that 1 over to the other side because I want to get tan x on its own. So I've got 5 tan x is equal to, so that's going to be a minus 1. Then what I'll do is, to get rid of the 5 tan x, I'm going to divide the other side by 5. So I've got tan x is equal to minus 1 over 5. Right, from there what I'll do is I'll be looking at this here and asking myself, is that positive or is it negative? I'll then be thinking about the CAST table, and what I'll be doing is I'll be ticking where tan is going to be negative. So I know tan's positive there and there, so it must be negative in the other 2 quadrants. So there's my 2 solutions there, in quadrant 2 and in quadrant 4. What I'm going to do first of all is I'm going to find the acute angle. Remember, the acute angle is the one that helps me work out the other angles. So let's go for it. So the acute angle will be the inverse tan, and remember I'm just going to use 1 over 5, and again I'm just going to say that I'm not using a negative. No negative value in there. Right, let's see what we get from there. So what we'll go for is, we'll go shift tan, so the inverse tan, and it's going to be 1 divided by 5, close the bracket, and that should give me 11.3 degrees. So I'm going for 11.3 degrees on that one there. Okay, just do it to 1 decimal place this time. What I'll then go for is, I'll go for my solutions, because this one here will not be a solution. Solution. Right, let's go for quadrant 2 first of all. So the quadrant 2. And remember, anytime I'm calculating something in quadrant 2, 180 minus the angle that I started with. I'll look at the quadrant 4 answer, so it's going to be quadrant 4, and remember, in that quadrant we start with 360 and we subtract the acute angle that we worked out. Okay, so 180, and what we'll do is we'll just add on to that 11.3, and what that should give me is 191. Oh, sorry, I've added. Let's do that one again. So that's 180, and what we'll do is minus 11.3, and that's going to be 168.7 degrees. So it's 168.7 degrees. And what we'll do is we'll subtract for the quadrant 4, 360, I'll subtract 11.3, what that should give me is 348.7 degrees. Okay, so the 2 solutions I've got, or my solutions, they're going to be x is equal to 168.7 degrees, and we've got 348.7 degrees. Okay, so that's us completed this work. This is where we should be with National 5, but certainly this would be applicable to higher maths, and especially if we were doing this type of work in radians, then certainly that would be in the higher maths curriculum. So hopefully this has helped you out, and hopefully now you ken maths.